Hi guys, today I'm going to be doing the worked examples from exercise 6.4. So this is teaching us the quotient rule, and it's of course from your Year 12 Jacplus textbook. So we're going to start with this one here where we've got the derivative of sine 2t over t squared. And what we can notice about this is it's not something where we can simplify and then derive in the easy normal way. So if we had something like x squared plus 3x cubed on x, then it would be inappropriate to use the quotient rule. You should simplify that or cancel down, find your common factors, and then you would have x plus 3x squared, and then you could differentiate that, and that would be much easier than doing it with the quotient rule. You could do it with the quotient rule, but it would be a waste of time. So in this case though, I can't cancel the t's here or anything like that. So I'm going to use the quotient rule. So I'm going to say, well, it's already y, so I can say let u equal, we put what's on top as u, and v is t squared. So when we did the product rule last time, we said that the first thing was u and the second thing was v. And I think it's really good to keep it like that, because then the first thing here is u and the second thing is v as well. So what we will find u dash and v dash as well. So that's just going to be 2t. And then the derivative of sine, remember sine looks like this, and we walk up the hill first. So it's positive 2 cos 2t. And one thing I noticed that is quite common, and I certainly do it, is even though if you know the derivative of sine and cos, you can accidentally write sine here. And I think there's one of my videos I actually do that in my circular functions somewhere. I'll have to go back and change that later. So now we've got our parts, and again it's a cross. The quotient rule is dy dx. And again, there's different ways to write this, but I like to write it like this. So vu dash minus uv dash over v squared. And remember from the product rule, we had a plus, and well, we didn't have it over anything. Well, that didn't matter which order you did. Now, because we've got a subtraction, it will matter. So let's do it. So vu dash, which is t squared, times 2 cos 2t, and we're subtracting uv dash, so 2t times sine of 2t, so over v, which is t squared, and that's squared. So let's neaten this up. So we have 2t squared cos 2t minus 2t sine 2t, and that's over t to the power of 4. And just be careful, this is a multiplication. In this case, it wouldn't matter if you accidentally added 2 plus 2, because it still equals 4. But often people will sort of just make a silly little mistake with the indices there. So we multiply when we got brackets. So dy dx, let's neaten it up, 2t. We can take out of the brackets, and we're left with t cos 2t minus sine 2t over t to the 4. And then of course, well, you can cancel this t with this. And look, I'm not going to write a whole new line for it. I'll just put the 2 here, and this will become a 3. And just make sure you complete the bracket. So there, I had a bracket here, and I almost forgot that one. Also, when you've got cos and sine involved, always look out for where you can simplify it in terms of if you have the Pythagoras identity, so sine squared x plus cos squared x will equal 1, or if you have sine over cos, it equals tan. So look out for that, because that's quite common, and you want to be able to recognise those. So that'll be the end of that one. We're not meant to sub anything in, are we? No, just differentiate it with respect to t. And actually, I should call this dy over dt. It's certainly not x, because, well, there is no x. So that's more like it. Okay, let's see. Next, find the derivative of f of x, and hence the gradient at where the x is 0. All right, so let's do that. we're going to say let y equal f of x, and I mean, you don't have to do that if you don't want. You could just leave it as f of x. There's not really any much value in changing it to y, only that's what we do in chain rule, and you know, why not do the same thing? Let u equal the top thing, which is cos 3x, and v equal 2e to the x minus x, and then u dash cos is this graph. So we're walking down the hill. It means it's going to go to negative 3 sine, careful not cos, and v dash is going to be, well, 2e to the x is its own derivative, minus 1. Okay, so now, well, cross multiply them. vu dash minus uv dash over v squared. So dy dx, and actually I might call it f dash of x. You know what, I'm going to get rid of that. We absolutely don't need that. We're not dealing with y at all. vu dash, so we've got negative 3, 2e to the x minus x sine 3x, minus uv dash, so 2e to the x minus 1 cos 3x over v squared. So v squared is 2e to the x minus x. Let's square that. And look, in this case, we're subbing something in. It's a 0, and so it won't be too much of a big deal if we don't, you know, factorize it properly, because when you sub the 0, it will work nicely anyway. But in any case, we could take out this 2e to the x, but it's not really going to help us, so I'm going to leave it as it is, and I'm going to sub in the 0. Neg 3, 2e to the 0 minus 0, sine 3 times 0 I should say, 2e to the 0 minus 1, cos 3 times 0, and 2e to the 0 minus 0 squared. And look, I think it's pretty obvious by this stage, and something that probably you're not going to stuff up, but just, of course, when you have something to the power of 0, it is not necessarily, well, it's not 0, it's 1. Anything to the power of 0 is 1. And furthermore, when we sine or cos something, or sine or cos is 0, it's not necessarily 0. So be careful. It's a bit of just a weird, silly mistake that you can make. So negative 3, 2 times 1 minus 0, sine 3 times 0 is 0, minus 2 times 1 minus 1. And of course, you don't need to write this whole thing out. It's just that I want to do it carefully so you can see how it works. 2 e to the 0 is 1 minus 0 squared. So f dash of 0 equals neg 3. So what have we got here? 2 times 1 is 2. And then sine of 0. So if we draw a little unit circle here, 0, sine is the y value. So that's going to be 0. Minus 2 times 1 is 2. Minus 1, oh, sorry. Okay, Google, stop. 2 times 1 is 2, minus 1 is 2. And cos of 0, so cos is here. That means 0 is there, and cos is the x value, that's 1. Over 2 times 1 is 2, minus 0 is still 2 squared. So f dash of 0 equals 3 times 2 is negative 6, but we're timesing it by 0, so it's just 0. And then minus 2 times 1 is negative 2 over 4. So I feel like, I see, I didn't do 2 minus 1. So 2 minus 1 is actually just 1. There we go. So it should be negative 1 there. So 1 times 1 being 1, and then over 4. So our f dash of 0 should equal negative 1/4. And actually that is all the examples we have from 6.4.